Yeah, given.
Only that's it, huh?
Yes, sir.
Right. Center of mass. So what is center of mass? The total mass of the body is supposed to act at a single point. That point is called the center of mass. So first let us discuss center of mass of a two particle system. Center of mass of two particle system. Two particle system. Okay.
Yes.
Center of mass of two particle system. So see here, I am considering two particles of masses m1 and m2. Say, let us consider two. This is one particle of its mass is m1, and this is other particle, its mass is m2. And these two particles, let us consider. So this is a x-axis, and this is a y-axis, and this is a origin. This is the origin. So from origin, the mass m1 is at a distance of x1. Let us consider, and the mass m2 is distance at a distance of x2. At a distance of x2. So now the center of mass of the system, the center of mass of the system. So from origin at this point, we consider the center of mass, the center of mass of above system will be. So it is only x coordinates. I'm talking about only a system. So center of mass of coordinate x equals to, you can write as m1 x1 plus m2 x2 divided by m1 plus m2. So this is the center of mass of the two particle system, that is m1 x1 plus m2 x2 by m1 m2. Got it? See, if we discuss special cases, for example, by using this formula, see, I will consider this is a mass m and this is also mass m, same mass, and the distance between these two will be x. Let us consider x. Now, usually where is the center of mass of this system? At center, na exactly? Yes.
So,
Yes.
At center. So at center, let us consider this distance is 2x1. Better, easy calculations. Now the center of mass of this system will be at the center. Let's see. We know that directly. By formula, we can check it whether you will get center of mass at the center or not. So x equals, what is the formula? m1 x1 plus m2 x2 by m1 plus m2. Substitute m1 equals to how much? M. x1 equals to how much? X.
yes, sir.
Yes, sir.
Yes or no? See, so we have to consider one point, fixed point. Fixed point. So consider this x1. Now what is the x1 ma? What is x1? This is the origin. What is x1? x1 will be 0, na? Getting my point?
Yes, sir.
X1 will be 0 because so the M1 where it is located at origin itself. Therefore, x1 will be what? 0. X1 will be 0 plus M2. X2 equals to how much? X,
Yes, sir.
X2 equals divided by M1 plus M2. M1 is also M and M2 is also M only. So finally, X equals to M2 into X by 2, M into X by 2M. So MM get cancelled. Therefore, X equals to how much you will get? X by 2, na? Yes? You from origin to this distance is X. Then where you will get center of mass? Exactly at center. At center means what is the distance? That is X by 2. Now center of mass, how much you get? X by 2. Correct?
Yes, sir.
So that is just I have explained example. No need to write this one. So this is the center of mass formula for two particle system. Two particle system. Understood? So let's see the different cases in this one.
Sir,
So okay. Yes.
I have joined the class right now. What did you do before, sir?
Oh no, nothing I had. This one I am teaching now.
Previous then we should not teach anything, sir.
No. This one. This is the first thing.
Okay, sir. Thank you.
Why?
No, sir.
Still only 40 members are kept. Still many are there. Around 60, 70 members are there. So if any of your friends are not attended, please inform them. Let them join. Huh? Right. Not able to hear your voice, Supriya. It's breaking. Right. Special cases discuss. So let's case one. Case one. Okay. Suppose if origin is shifted to M1. So if origin is shifted to where? M1. So at M1 it is shifted. So if it is shifted to M1, then so what will be the center of mass? C. So this will be M1 and this will be M2 and now this is the origin. So O. And as usual, this will be how much? X2. This is 0. X1 will be 0, na? Like before. Then what is the center of mass that particular time? Center of mass X equals to what? So M1 into X1 will be 0 plus M2 into X2 divided by M1 plus M2. So finally you will get M2 X2 divided by M1 plus M2. Understood? Understood or not?
Yes.
Yes, sir.
Right. Case 2 if we consider. Case 2. So if origin is shifted to if origin is shifted to M2. Clear? So if origin is shifted to M2 means so this is M1 and this is M2. So here the origin, no? This is the origin. Yes? And now this is how much the distance will be x1 now? X1. Understood? Diagram. Now from this center of mass x equals to what? m1 into x1 plus m1 into x1 plus m2 into m1 plus m2. So finally what you will get? So x equals to, that is m1 x1 by m1 plus
M2.
so this is the center of mass case. Case 3, case 3. If origin is shifted to center of mass, so actually you have to consider this one as negative. Why? Because see, listen here, second case 2, if you observe case 2, if you observe, x1 is minus x1 or plus x1? Minus x1 na?
Yes.
X1 is minus x1.
This is the origin, and so we are measuring the distance from negative x-axis, like this we are measuring, therefore it will be what? Minus, so we can keep minus, so minus m1 x1 by m1 plus. Okay, now if origin is shifted to certain center of mass, so where it is shifting? At center of mass. So let's see, if it's shifted center of mass, what will happen? So for example, so this is a mass m1 and this is a mass m2, and for example, so this is a center of mass. This is the center of mass, let us consider, and the origin is also same. The origin is also, point of taking is also same. Then let us consider this one is x1, x2, and this one is x1. Understanding? See, if origin is shifted to at center of mass, then center of mass will be at origin, na? That is x equals to 0, na? Yes,
Yes.
x. See, this capital X I am represented as center of mass. So therefore, the capital X would be 0, na? 0. Why it is 0? Because it is at origin. The origin is at center of mass. Therefore, center of mass equals to 0. You will get 0. So from this, so it will be 0. What is the formula for center of mass? X equals to, usually we can write mx1 plus m2 2 divided by m1 plus m2. And here minus m1 x1.
Yeah.
Yes, minus m1 x1 plus m2 x2 equals. So, but x equals to what? 0. That is center of mass x equals to what? 0, because it is at origin. So if it is 0, 0 into m1 plus m2, 0 na?
Yes, sir, 0.
So finally what will be? Minus m1 x1 plus m2 x2 equals to 0, and finally you will get m1 x1 equals to m2
M2.
So these are the different cases in center of mass of two particle system. So remember one thing, we are measuring the distances from the origin. So from the all from the origin itself. Finished, huh?
Yes, sir.
Shall I go for next one?
Yes.
Yes, sir.
So next one, coordinates of center of mass. Code of center of mass. See, suppose let us consider n number of particles, or you may consider 1, 2, or 3 under anything. Suppose if you consider n number of particles, so all these n number of particles, so they are in 3 axis coordinates. No? So I will consider first reference frame. So that is x, y, and z axis. X, y, and z axis. So usually, if you consider before we have considered two system. Oh, that is 1D. Now see, this is M and M. Center of mass will be at center. Suppose 3 are there, then the center of mass will be thought like this. So we can define it. If we symmetrical bodies and all, we can know. So if we don't know the symmetrical bodies and the particles are there in that different places, then how to find the center of mass? So see here in terms of coordinate system, let us consider n particles. This is M1. And its coordinates are, let us consider x1, y1, and z1. And I will consider other one, that is m2, mass is m2, and its coordinates are x2, y2, and z2. Like this, n number of particles I will consider. Next particle, that is m, mass of the nth particle is mn. Then what are the coordinates? That is xn, yn, and zn. Okay, so system of particles I have considered. Each particle mass I have represented and the coordinates also represented. Then here, so we have to find the coordinates of indivisible axis. Indivisible axis. So indivisible axis, if we consider of mass along x-axis, center of mass along x-axis equals to. What is the center of mass of two particle system? That will be what? M1 x1 plus M2 x2
M2
by.
x2 by M1 plus M2.
In the similar way for n particles, you tell n particles. How you can write? M1 x1 plus
Plus Mn x.
x2 plus
Okay. Yes.
M3 x plus and so on.
M3 x3.
So Mn x divided by
M1 plus M2 plus M3
M1
dot
plus
dot plus Mn.
M2 M3 plus and so on plus
Mn.
this is a coordinates of x-axis. So this is a means if you calculate this one, then you will get center of mass of x along x-axis. Along x-axis. Now along y-axis, how we can write? So center of mass along y-axis, which is equals to, tell me, m1
1y1,
M1 Y1
2y2, m3y3,
into Y2 plus M3 Y3 1 plus Mn Yn
very good, divided by
by M1 plus M2 plus M3
m1 plus m2 plus
1 by Mn.
the similar way write z also, center of mass of z, that is m1 z1 plus m2 z2 plus and so on plus mn zn divided by plus mn. So this is the coordinates of center of mass. Do you understand?
yes sir.
Yes, ma?
Yes, sir.
See, so now we will get the x coordinate, center of mass of x coordinate, y coordinate, and z coordinate. Let us consider, suppose say example, you will get here. Yes, okay, you will get here. So example, the center of mass of n particle you will get here. So then what is the coordinates these are? That is x cm, y cm, and z cm, right? So and each one having, then what is the distance? So from origin, the distance from the origin. So what is the distance now? How we are finding the distance? So the distance from the origin, the distance from the origin the distance from the origin. So what is the distance? The distance d equals to, how we can write? So we can get an answer, that is resultant vector. So xcm square plus y cm square plus z cm. Nothing but equation. So this is distance. Understood? This is position vector.
Understood.
And I hope position vector can be expressed as y square plus z square, no? So but we are calculating a distance of center of mass, so that's why square root of x square plus y and l square plus z square. Understood? Hello, yes.
Sir.
Hello, go for next one.
Sir.
Okay, sir.
Yes sir.
Have you got today's math? Any
Oh,
of
yes, sir. Yes, sir.
you? It was also right. History created today actually. History.
Yes.
there is no cricket club also. Only you are there.
Yes, sir.
Yes, sir.
There,
How many of you watch today's match? Why is it? So they want us to study, they want the parents want you to study very well, so they remove
there, sir. Yes, sir. Intended.
So that's why you should focus on both things, studies and all. So always if TV is there, it won't be TV. Otherwise, that's why parents will go like that. Okay. Let's go for next one. So next one, position of center of mass. Center of mass. So position of center of mass. So let us consider any particles. Okay. So any particle. So we may measure the dimensions as 2 dimensions, that is x, y, and z. So this is one particle. Its mass is m1 and its position vector position. And so let us consider this m2 and its position vector r2. Like this, we consider number of particles and so this is n mass n1 and position vector r. Position vector r. In terms of position, we are considering. So now the position of center of mass will be a position vector. So we can calculate position vector also. Position vector center of mass. So the position vector of mass, let us consider the position vector CM as matrix CM. RCM means position of center of mass. R is the position vector. So in terms of vector, if I write it is equals to this will be m1 r1 plus m2 r2 plus random particles. It will be m1 rn divided by
Temporary variable, sir. M2, M1 plus M2 plus. So on plus M.
plus. So see here, m1 plus m2 plus m1 will return as like this. So that is m1 plus m2 plus and m1 plus m1. Can we write as sigma I equals to 1 to m I, right? So out of this also I am as total mass of the particle. Let us consider printed with the capital. Let us consider m. Shall we write? I will write like this. Now what is RCM? Center of mass. Position vector of center of mass equals to m1 r1 plus m2 r2 plus and so on divided by m. And finally, so m RCM, which is equals to m1 r1 plus m2 r2 plus and so on. Got it? Right,
Yes, sir.
So this is the center. This is the position of vector of center of mass. That is RCM equals M1 R. So this is capital M is the total mass. Capital M. So you send that side the M, then finally you will get so M R M, which is equals to M1 R1 plus M2 R2 plus and so on. Plus M1 R. So this is the vector equation vector of the center of mass. So these all are when the objects are at rest. Suppose if the objects are in motion, okay. So this till now we consider the object is at rest, then its center of mass we have considered. Suppose if the object, see, for example, if we consider an object, this one object, this is an object. So we are considering some system, that is XY system. We consider. Now this object is at rest, then its center of mass will be exactly at this point, and we can define it. Suppose if this object is in motion, if the object is in motion, the center of motion, center of mass is also changes, no? Position of center of mass changes, right? Position of center of mass change aguttilla. So in such cases, if position is changed with respect to time, then some other points or some other variables we have to define, that is velocity, acceleration, etc., etc. So next one is velocity of center of mass. Velocity of center of mass. Velocity of center. Usually, what is the definition? A general definition of velocity? Rate of change of
Displacement.
A general definition of velocity is nothing but the rate of change of displacement. So
Rate
here,
of change of position vector.
So rate of change of position vector is also a displacement. Now see, let us consider the position vector, that is RCM. Same equation we consider, that is M into RCM, which is equals to M1 R1 plus M2 R2 plus and so on. So differentiate above one with respect to time. So differentiate with respect to time. So if we differentiate here, M, mass of the system is constant, therefore M into dRCM divided by dt na, equals to mass is constant, that is M1 into dR1 by dt plus M2 into dR2 by dt plus and so on. See, rate of position vector equals to what? Velocity na? Position vector, nothing but displacement. So rate of change of position vector is also a velocity. So therefore we can write V. It is not only a position vector, it is position vector of center of mass. Therefore this will be position vector of, a velocity vector of center of mass equals to M1 into V1 plus M2 plus and so on. This is the velocity. So center of mass of velocity will be V Cm equals to, we can write M1 V1 plus M2 V2 plus and so on divided by total mass. This is the velocity of center of mass. Finished, huh?
Yes.
Right. So in the similar way, acceleration of center of mass you have defined. Okay, momentum it is. Momentum. Linear momentum, you know. So linear momentum of what is linear momentum? Linear momentum of center of mass, COM. A shortcut I have written, you write full form. Or else if you understand, you can write say shortcut form only. Center of mass, linear momentum of linear momentum of COM, center of mass. See, what is linear momentum? Linear momentum is nothing but a product of mass into velocity, no? Yes.
Sir.
So product of P equals to product of mass into velocity. Now consider a previous equation. If you observe once, the velocity of center of mass equals to m1 v1 plus m2 v2 by m and so on divided by m. The above equation, if you observe, so that is m into v c m total mass, which is equals to what? m1 v1 plus m2 v2 plus and so on. So see here, m is the total mass and this is center of mass, velocity of center. So from this what we can write, m into v is nothing but a momentum. Since momentum of center of mass, therefore cm equals to p1 plus p2 plus and so on. So this is the momentum of linear momentum of center of mass. And acceleration of center of mass. So acceleration of center of mass. So what is acceleration?
Yes, sir. Rate of change.
So rate of change of velocity. Now consider the velocity vector. So acceleration, that is this equation only, above equation only you consider, that is m into, so okay, I will write in next page. If you finish, I will go for next page. Have you finished?
Yes, sir.
Okay. Right. See. So acceleration of center of mass. Center of mass. Okay. So we know that is total mass into velocity of center of mass, which is equal to
Sir, can you go to previous page, sir?
m1 v1 plus
Sir?
after finishing tell me,
Okay, sir.
got timetable, huh? Class is there?
Yes, sir.
Done.
Yes, sir. 3 o'clock class is there, sir.
8 to 6. Okay. Finished, huh?
Yes, sir. Done, sir.
So we know that that is center of mass, velocity of center of mass, that's m is m2 m1 v1 plus. So it will be m2 v2 and so on and so on. So now from this, so differentiate with respect to time. So differentiate with respect to time, then it will be mass will be constant. So d by dt of velocity of center of mass equals to m1 into so d by dt of v1 plus into d by dt of v2 and so on. So we know that the rate of change of velocity is acceleration. So finally we can write so m into center of mass equals to m1 v1 m1 a1 plus m2 a2 plus and so on. So finally acceleration of sense equals to m1 a1 plus m2 a2 plus and so on divided by total mass. Total mass. So this is the acceleration. Clear? So note if we consider note. So if two particles or objects, two bodies or two particles of masses m1 and m2 are in motion, are moving, okay, are moving with velocity, so with velocities v1 and v2, v1 and their acceleration and their accelerations a1 and a2, a1 then see. So if two particles, see, well, let us consider two particles I have considered. One is moving like this with the acceleration as shown in below. As shown in figure. As shown in figure. Let us consider as shown in figure. So if we consider two bodies, one is moving with velocity v1 and r acceleration, velocity and acceleration. Other is moving like this. So velocity or acceleration. And these two are making an angle theta. These two are making an angle theta. Then what is this? Just forget everything center of mass. Just see, tell me the resultant vector of these two. What is the resultant vector? It's diagonal, no? Yes? Yes or no?
Yes, sir.
Diagonal, right? So resultant vector will be diagonal. So this is the resultant vector. So nothing but a center of mass. Center of mass of, and resultant velocity, what we can write? That is v1 square plus v2 square plus square root of v1 plus v2, 2 v1 v2 cos theta. No? Do you remember that? So therefore,
Yes, sir.
velocity of center of mass, velocity of center of mass. So velocity of center of mass will be VCM equals to square root of, you will get m1 v1 square a square plus b square m2 v2 square plus 2ab cos theta, 2ab, that is m1 v1
2ab cos theta.
and m2 cos theta divided by total mass, that is m1 plus m2. And acceleration of center of mass. Acceleration of center of mass. So if we consider acceleration of center of mass, how we can write? Square root of, tell me, m1 a1 square
Yes, sir.
plus m2
Into A2
a2
square
into
2 into M1 A1
a1
M2 A2 cos theta.
into a2 cos theta divided by
M1 plus
m1 plus m2. Understood? Then from this you can write the special cases. So the special cases is how you can write, that is theta equals to 0. If theta is 0, what will happen? VCM equals to m1 v2 by m1 plus m2. Like that. All those things you have to write. Special cases. Right. Understood? Any doubts?
into.
Fine. So fine. We'll continue in the next class. So right now, no classes have already
No, sir.
there.
No, sir.
Shall I end the
No, sir.
fine. Bye bye. Take care.